Cool. We got everything up and running. And it's 3 o'clock, so let's get started. Okay, welcome to chapter number 9 of the server and vServer performance optimization. This is second to last chapter. This one is a little longer than the previous, but not too long. vCenter is an important aspect to this entire infrastructure. It needs to have plenty of resources to run effectively and quickly to handle all the complex systems that it oversees. By itself, you have the vCenter server and its services, and the platform service controller. If any of these are eating up too much resources or don't have enough resources, your entire database will suffer. As you can see here, there's a lot of communication that happens between the two main services that comprise your management node. You have for the end user, the web browser. To that, the vCenter server has to have the service vSphere UI running, which is connected to VPXD, which is connected to another service, interconnected to a database with a couple others. Through VPXD, it also communicates directly with the physical hosts. The UI can connect to single sign-on services like Active Directory. And VPXD also connects to other directory services. All of this is not any lightweight tasks. This is actually a lot of heavy, intensive programming that will be done in the background in order to ensure that your systems are fully functional and you get the full extent of what vCenter can do. Considering a number of factors that you need to monitor and maintain acceptable levels of performance, you have the platform service controller itself, the number of concurrent vCenter server operations, CPU and memory, network, database, and user interface. So starting with platform service controller, the default for it is 2 virtual CPUs and 4 gigabytes of memory. Unless you're dealing with larger systems, that should be sufficient. If you have separate nodes, you're going to have that same separate configuration everywhere else. Ideally, you want the latency between your platform service controller and your vCenter servers to be less than 30 milliseconds, because a lot of this happens quickly, and a lot of this is automated, as you have seen in the various chapters that we've covered. So high-speed communications is essential. The hard limit that vCenter has is 640 concurrent operations before a new request is queued, and 2,000 concurrent sessions allowed before requests are rejected. Now, if someone in security, you see those, then you would create ways to deny the service, those services, and reach those numbers so that everything else dies. As a general guideline, your CPU performance should not go above 70%. If it does, then we probably need to add more CPUs to the vCenter server or add another instance to load balance across instances. This system does use Java, and so if you see it consuming a lot of CPU, you'll need to increase heap memory size for that service. And of course, any plugins that you add to the system later will also contribute to CPU usage. Memory will follow the same guideline of it should not go above 70%. If it does consistently exceed 70%, then check vCenter swapping, check which services are using high CPU and which ones are using a lot of memory, and then add more memory as needed. You can see in your appliance management or within the VM zone graphs, see the usage of CPU and memory. And again, if it's above 70, if either one is above 70, consider adding more memory or seeing why it's using that much memory and rectify that issue. You can use Vim top as well to monitor resource usage, just like ESX top. You see the processes, you can dig in deep. You can also do the same with vCenter's own graph system. Same with this, showing you what process is using how much resource. And here's a quick question. It's a general guideline which you should keep CPU and memory usage by a vCenter server instance below which percentage? The answer is 70. Again, just like CPU usage, you can monitor memory usage using a Vim top as well as the GUI method. We can also view the amount of memory allocated to a vCenter server service with Cloud VM RAM size. And it'll tell you how much RAM is being used for each service. The heap size can also be brought out with a -J for several Java services. And then to change it, it would be in this manner. You don't have to reboot, but you can individually resize a service. With this example, we see that vSphere client has now grown to 700 megabytes. Your network. Host-to-host bandwidth is typically more critical than vCenter server to host. In most cases, operation latency is bound by the host latency. Your vCenter server database will always play a critical role. So minimizing that latency is important. If you are using a Windows vCenter, so if you're just using an external database to be the database for ESX server, you'll see some of these guidelines could apply. If you're using the built-in appliance, then it's already embedded into that, so you don't have to worry about latency if you have it. If you are using the OVA file turned into an appliance. So again, if you're running a database outside of vCenter, like a custom built or running a database on a different box, you would use these something like this to view the network activity and see how many packets are being dropped between vCenter and the database. And you want to minimize the latency, minimize the number of drop packets, because again, it's highly important that vCenter can easily communicate and quickly communicate with the database. Under normal vCenter server usage, your resources like CPU, memory, disk, and network should not be saturated. There is going to be some transient high CPU usage during a rollup or an update. Those are not a problem, but consistently high CPU usage is not normal. Again, things to worry about if you have a database separate from vCenter. Using external, you could use tools to like recompute the database statistics, to purge database tables, to check, like verifying queries, seeing where is the slowdown, to fix that so that your database will work as fast as possible. When you're changing some settings, make sure that everything is functional. You want to make sure that the network counters are increasing significantly, that you see that there is a positive change in the communication between vCenter and the database. If you've ever taken out that appliance and you see that it has a number of disks and you wonder why does it have so many disks, this is why. The first disk is the boot and the swap. The second is the temporary. The third is another swap. The fourth is the core dumps. The fifth is the log. 6 is database if you're using the built-in. The database log, seat, net dump, auto deploy, image builder, and archive. This is good to know. Should something happen with the appliance and you want to get the logs, you would specifically look for VM DK5 and get the information off of that. You can use VAMI to monitor disk usage by each partition if necessary. I have seen where the older versions of the appliance will eat up all the log file space and then it prevents everything else from working. So I would suggest to keep an eye on these hard disks and make sure that they don't fill up, because once it does, vCenter acts really slow. Services are just all over the place. It's just not a good day. Of course, you can monitor disk usage directly and use VimTop as well. SEAT, if you were wondering what that stands for, it's stats, events, alarms, and tasks. And here's a question. Host-to-host network bandwidth is typically more critical than vCenter to host bandwidth. And the answer is true. A second question. Which of the following tools can you use to monitor the free space in vCenter server database? And the answer is the first and the last. That is the end of Chapter 9. Chapter 10, the last chapter in the ONS section, and also the last chapter of this course. Security is, of course, important with virtual machines. They handle sensitive data. They can be the place where we store very sensitive information, so it must be secured. It also could be running our critical infrastructure, and thus also needs to be secure from attackers who are trying to bring down our infrastructure. vCenter already has tools and settings that can be applied to secure your infrastructure. It's just a matter of going through them, setting them, and then checking them regularly, because with security, nothing is set and forget. It is always a constant review. So 1 of 4, host access and authentication. Right off the bat, within ESXi, you have a firewall that you can use. You have a very limited number of services and a security profile that you can implement. In the firewall, you can open certain ports. It is a service-oriented stateless firewall. So you can make changes to specific services like SSH in this example and say what IP addresses specifically can connect to this service if you want it on. Or you could turn off that service and then prevent SSH. By default, SSH is turned off. Your services, which you'll find under Configure Services, you'll see a small list of services. Again, to minimize the potential ways that an attacker can leverage, ESXi is trimmed down to just the bare essentials. To that end, only turn on things like the shell and SSH when absolutely necessary, and then turn them off when you're done to prevent any subsequent attacks, to prevent any excess doors from being opened. You can enable lockdown mode. This is where services are disabled or accessible only to certain users in certain ways. You have disabled, normal, and strict. By default, this is turned off, and you can enable it if you want. In normal or strict, no users but VPX user have authentication permissions. You also can't do any operations against the host directly. When normal lockdown mode is enabled, the host can be accessed only by vCenter server, like through the client. The direct console user interface that you normally get when connecting a monitor to the ESXi box is restricted only for users in the exception list and those who have the DCUI access. Everyone else is kicked out. If you have the shell or SSH enabled, only the admins can log in. Under strict, you can only get to it by vCenter. The DCUI is completely disabled and nobody can log in. If shell and SSH are enabled, only admins can log in. Now, this can be a double-edged sword. It is a good idea to prevent anybody from being able to physically walk up to the system and interacting with it. That's good. Now, if you lose vCenter for whatever reason, and you have this enabled, now you have an interesting problem. Not only can you not get through vCenter because vCenter itself is down for whatever reason, you also cannot access the physical ESXi because strict lockdown is enabled. So when you do something like strict lockdown, make sure that you know what you're doing and that you have a plan, because the risk of vCenter dying and locking you out from everything is there. So for example, have vCenter load balance, have a second vCenter on the network, have another way to prevent yourself from getting locked out of your own infrastructure. You can use authentication services to connect to a domain so that you don't have multiple credentials everywhere and they're all managed centrally. It is completely possible to join hosts into a Active Directory domain. You can add the hosts through the authentication proxy service. It'll join hosts unattended to the domain without you having to do it afterwards. So you can set this up, and then as you add more hosts later, they'll also be added to the domain. And you'll have a lab in that. There's a number of aspects in securing vCenter, from the hosts to the virtual machines to the vSphere network. Here are some links that could be useful for you. These guides will get updated over time. So definitely make sure that you are getting the latest version for the system that you have. That configuration guide is in the form of an easy-to-use spreadsheet for you. There are examples that will help you script your automate security checking. You can do things like hardening, things that are site-specific, and audit. Always start with audit to see where your infrastructure is, and then from that audit, go forward in what you need to do. As with anything security-wise, everything is risk-related. So you want to set up as you audit and you assess what needs to be taken care of. You set the impact level and you put everything in order of priority. What is highest priority that needs to get taken care of first, and what can wait. Strictly controlling access to vCenter will increase the security of the overall system. Since you have seen that vCenter is your gateway to do a whole lot with this infrastructure, it must be protected. So you could do things like creating, having certain users who can access it. Never ignore certificate verification warnings, setting a password policy, and limiting who can connect on the management network. You can set some of these things up in vCenter, like disabling SSH and whatnot. You can use TLS to secure the communication between the user and the system. If you are running vCenter on Windows, there are a number of things you can do. Like RDP should be set to the highest level. Honestly, you shouldn't be using RDP because RDP itself has been broken. So you would want to use another way to get remote control in a more secure fashion. For systems that are using the appliance, make sure that NTP is running from a relative time source like pool.ntp.org. Restrict access to the components. Make sure that it is fully up to date. The network, ideally, should be behind the firewall, should have its own physical switch. And if that's not possible, then use VLANs to hide the management network. Because again, access to the management network means access to vCenter, and that is just a gateway into your whole infrastructure. Securing the hosts themselves, again, prevent the root user from logging on. Use Active Directory if you have it. Use the vSphere client, managed by the vCenter server instead. Keep the host firewall up. Disable any access doors like SSH. Enable lockdown. Have signed certificates, valid signed certificates. Hosts that have UEFI, make sure that that is running with secure boot. ESXi supports secure boot. So you can enable that to prevent an attacker from physically connecting to the system, rebooting and running like Kali Linux or Parrot OS off a USB. It won't allow it. Having a secure boot will provide security at the complete boot stack, from verifying the bootloader and the VM kernel all the way up until everything is up. If your host has TPM, the Trusted Platform Module, you can enable the use of that as well. This has been included since vSphere 6.7. TPM will attest to the hardware that it's connected to. So again, it's another way of verifying that the drives that have ESXi have not been taken and moved to another system and are trying to be read, for example. You can do also remote attestation process to again verify that your hosts are the hosts that are connected to your center, and they all verify themselves and they all verify to vCenter that they are who they are. Again, in order to use this functionality, number one, you need to have secure boot enabled. You need to physically have the TPM chip and at least vCenter Server 6.7. Here's a question. If UEFI secure boot is enabled on a host and an invalid VIB signature is found during the boot sequence, a purple screen appears stating that UEFI secure boot failed. And the answer is true. vSphere is already compliant with FIPS 140-2, a security standard specifying the requirements for cryptographic modules. So you can use vSphere in an environment that requires you to meet this standard. By default, it already does cryptographic operations in that mode. So you don't have to do anything extra. It's already there. The management interface uses FIPS certified cryptography to secure communication. Any connection, such as the host client or vSphere client or even SSHing, is already compliant. You can enable and disable if you need to, but I would suggest not disabling it. It's already built in and active. Why take it away? Virtual machines themselves can be protected. Of course, doing things like keeping all those systems patched, installing antivirus and anti-malware systems, disabling unnecessary functions, restricting the user who can connect, using templates, and all that will be useful. Here's a quick matching activity. These three match with which on the right? And that is the answer. Lesson number 3, we are halfway across. Certificates. Certificates are very useful in verifying the system that you are running. Identifies they are who they say they are, has cryptographic rules in order to ensure that the data being communicated from client to server is secured. You have many CAs like commercial and communities, like CA Cert, Let's Encrypt, and others. By default, vSphere comes with some certs, and you can change those to use others. VMware CA can issue and validate certificates. But again, if it's not already added to a browser, the browser will normally freak out. The VCES, or Endpoint Certificate Store, will store those certificates, private keys, and anything else that is necessary in order to use that communication. If you're not going to use the VMware CA, no problem. It'll still be used to store the certificate keys and other information if you get a certificate elsewhere. Different types of certificates used are the CA certificate, the solution user certificate, and machine certificates for the individual hosts, the vCenter, and the platform service controller. In this way, at all levels of communication in vSphere, everything is secured. The CA cert is a trusted root certificate that can be used to issue other certs like single sign-on. If you trust that CA, then you implicitly will trust any others that are issued from it. Again, in-house certs or self-signed are the ones that you normally start with and will create some issues for browsers. But if you accept it, then it'll take them. But if you are dealing with sensitive information, you will want to use an actual signed certificate from a trusted CA. Here's the process of that chain of trust, where you have a outside certificate authority like Let's Encrypt, and the client system who trusts that, and then through that they can create subsequent certificates and share with each other. This is a 2-node chain of trust. This is a 3-node chain of trust, where you have an intermediate just in case. Since 6.0, we have various services that are running, each with its own certificate, in order to be unique, again, to ensure multiple communication across the board is secure. So here are the number of ports that are being used. In 6.0 and above, you're using over 25 services that require authentication with certificates. Each of these endpoints can be combined through a reverse proxy. The solution user certificate mentioned earlier, those are used by vSphere to authenticate users to the vCenter server. The default ones that exist are the following 4 that are normally used to communicate from users to the system. Machine certificates are generated by the VMware CA and stored locally on each host. And those have 3, the reverse proxy, VMDir, and vCenter. Here's a summary of those slides put together in a chart. What they are, who creates them, and where they're stored. Another question? The VECS is a repository that exists on every management node that stores vCenter server certificates and ESXi host certificates. True or false? False. The CA modes. It can function as a root CA, which is default, the subordinate CA, or custom. When in root mode, which is the default, it creates a self-signed certificate. The CA certificate is capable of issuing other certificates. In subordinate, you replace the default single or self-signed CA that was created, and then you replace all the other default certificates after implementation. For vCenter servers, You should replace the certificates in the following situations. When you want to replace the root, when you switch to subordinate, or when you're replacing all the certs with enterprise or third-party certs. There is a certificate manager that will help you do these things. And you have a number of options with it. If you're replacing certs in root mode, this will be the steps that you'll need to take. You'll create the new root certificate. You'll replace it and remove any old ones. With it, if you're replacing with an enterprise, you'll have a CSR to connect with, and then import the new cert and regenerate as needed. You can also do custom certs as well. Replacement options, because certs should be replaced regularly. You can use thumbprint mode, enterprise or third-party certificates, or use the CA. Again, the default one that's created is normally not trusted by browsers. So if you're dealing with sensitive information on a critical infrastructure, you're going to want to switch from that default to something else that's more appropriate. If the CA is not available, you will not be able to add new hosts or refresh certificates in any host. So it is important to keep up your certs. And you will have a lab on this. Lesson number 4, securing the virtual machines. Since the sensitive data will be used, processed, computed within virtual machines, it's going to be imperative to ensure that the virtual machines themselves are secured. You can use virtual machine encryption in the following ways. Where we can secure the metadata files such as NVRAM, the storage, key control, and access. VM encryption works within the VM itself without requiring you to install more tools or outside third party. It's already built in. You just have to enable it. And it'll be uniform across all guest operating systems. The VM encryption architecture, or the way that you can encrypt the VM, would be through the key management server, or KMS, the vCenter server, and the ESXi host. The KMS, or key management system, has a number of characteristics, can be accessed over IPv4 only, v6 only, or mixed, can be configured with a proxy server, has certain clients that it can connect with. You can create clusters on this critical role. So in this way, we could separate certain VMs from others. vCenter server plays a role in storing credential information and identifying keys by a UUID, managing permissions, and records events. It itself cannot be encrypted, but the VMs that it manages can be. So between these two, vCenter communicates with KMS in order to get the proper keys to run certain VMs. But like I said, vCenter itself cannot be encrypted. You would use those certificates to work with the KMS vendor. You can make ESXi hosts cryptographically safe in order to ensure that whatever is running in that VM is secured. Whenever an encrypted task is going to happen, it'll run on a separate key and a separate cluster. Those keys will be retrieved for that action and installed on that local host. Ideally, if you're going to run encrypted VMs, you would want to run these VMs on a separate cluster, a separate host than your other systems. The flow would look like this, where a key is requested. The KMS will give a VM a key to vCenter server, otherwise known as the key encryption key, or KEK. That will get passed to the host itself. If it belongs to a cluster, then it'll get that for each host in the cluster. Again, itself is not stored in vCenter, only the ID of the key is, in order to ensure security, because if vCenter gets breached or compromised, the keys won't be accessed. Then we create the data encryption key. That's used to encrypt the VM and its disks, and then is kept in memory until the next reboot. Pretty interesting system that's already built in. Here are the different keys that work with this infrastructure. Oops. Well, ASX host can pull the key when required? No. vCenter server admins have the cryptographic privileges, but not all admins should be able to control these keys. That should be given to a different user to manage, because you don't want one person to have complete power over everything. You want separation of duties. There is a no cryptographic administrator role that you can enable or disable as needed. There is a storage policy that you can use to ensure that the data being saved is cryptographically sound, already built in. And you can encrypt new VMs as well. It is possible to take a existing VM and encrypt it. It has more steps, but it is completely possible. You can back them up. You have three ways of using SAN mode, hot add, or NBD SSL in order to back up an encrypted VM. There are some pros and cons into these three different modes. So the best practice would be see what works best in your environment. In 6.7, you are able to suspend and resume encrypted VMs, take snapshots, and unlock encrypted VMs. So if you need to unlock a VM, it takes a couple of steps. Again, you'll need to get the required key from KMS to unlock, and then you'll be able to use it. Here's another question. Which of the following predefined vCenter server roles must a user have to perform cryptographic operations? Administrator. Core dumps are saved during a system crash. They're saved in var core. It's important to protect these core dumps because they have a lot of information about the system that can be used to get in. And if the core dump happens on the host, the core dump may have sensitive customer data. Dumps can be encrypted. That is completely possible to do as well. Essentially putting them in an encrypted envelope. You can provide passwords to encrypted core dumps so that they're not just accessible to all. It is possible to use vMotion with encrypted VMs. So that's already built in. Don't have to worry about that during a memory migration. It just has to be enabled in vMotion because it's well, by default this is set in opportunistic, but you would have to set it to like required to ensure that from host to host it's always secure. In order to do this, of course, you're going to need a couple of changes to make sure that it will work. It is also possible to secure the guest operating system with EFI or secure boot. So you'll have not only secure boot on the local host, but you'll also have it in the VM. You can use TPM as a virtual crypto processor or virtual TPM. That is completely possible. It is, as long as you actually have TPM on your host, then the virtual can take advantage of it. So like I said, you'll need at least 6.7. You'll need server. You'll need the KMS system. The virtual machine will need to have EFI. The hardware will have to be 14 or later and run something like Windows 10 or server or anything that's up to date. Windows 10, Server 16, and 19 have this virtualization-based security. It works in Hyper-V. It also can work in VMware to, again, ensure security to the VM. It has some requirements and it has some limitations since it's more of a Microsoft technology than a VMware technology. You can enable it when you set up a Windows system. You'll see that little checkbox. You won't see it for other OSs, but you'll see it for those. And of course, keep up to date with new certs and information that you'll need as new information comes out with VMware certs, which is now talking about a whole different thing. So with that, we have completed this entire course. As a note, this course will actually no longer be taught at Cabrillo College. We are going to roll this subject into new classes that we're building that are all about the cloud. So VMware will be part of that. So all these videos and the course will be available till the end of time through my site. All these videos will be kept up on YouTube as well. So feel free to check them out in the future. Use them as reference. Use the content as reference. But as far as we're setting up for next school semester, we will no longer offer CIS 174 at Cabrillo. If you have any questions, feel free to reach out to me via Discord or via Twitter. But this is your Professor Urban Lembu signing off for the last time.